In the class, we discussing about a simple case study. So myself, Arun Kumar, Department of Mechanical Mechatronics Engineering at SNS College of Engineering. Okay, and my students, myself, Darun from EADS department, and Vijay from first year EADS department.
And Vika from A. And Kavya from AADS department at SNS College of Engineering.
Yes. So today what case study we have taken for here is, and it is a simply the external lamina. Okay, so the external lamina have been placing at a certain condition that is called as the inclination, or there's the inclined HP or inclined V, whatever you have to take. Okay, so you have to construct the regular external lamina for the given things.
First of all, for the Sarthi, we took the question. In that, we took the regular hexagonal lamina as 25 mm and the lamina restricted on the horizontal plane, horizontal HP and VP. And next, we took the 45 mm degree HP lines, and regularly we took the top one HP and the bottom one VP. Next,
So here we can take three cases. As per the hexagon rule, there will be three cases using the front view and the back view. The front view will be, the hexagon plate will be parallel to HP. The hexagon plane will be perpendicular to the HP and parallel to the VP in the second case, and the third case will be inclined. So now we are going to see the case that was inclined. Hexagon plate in the HP. So the front view for us will be a hexagon and the top view will be a straight line. So now the next will continue.
So, okay, I'm going to explain how to the 3D dimensional external lamina to 2D diagram. So, I draw a reference line, and the above the reference line is VP, nothing but vertical plane, and below the reference line is HP, nothing but horizontal plane. First of all, the question, every side of the hexagonal is 25 mm. So, every side of there are 6 sides, and every side is like 25 millimeter. And one of its corner is on HP. So, if the one of the corner is HP, so the one of the corner is parallel to HP. And then the inclination at 45 degree to HP. If the inclination to HP, the diagram is under the reference line. If the inclination to VP, the diagram is above the reference line. So it is like a simple shortcut. And then I named as here sides of the hexagonal like A, B, C, D, and I marked this is a objectal line and this is a position line, and due to the position line, I marked the name as A dash, B dash, F dash, C dash, E dash, and D dash, and then I using a ruler and measure this A dash to B dash millimeter distance, and then I place this projector and take 45 degree line, and the same distance is drawn in the place, and then here also the horizontally position line, and this is a vertically position line, and the point another point A B C D line. So this diagram is projected as this way, like if the inclination at the VP is like this diagram, this is a circular lamina. It is like this diagram is coming under this form, and this conclusion is given by.
It's going to be part of conclusion. Projection of the hexagonal solid is a 3D dimension, like hexagonal from the hexagonal prism onto a 2D paper. And hexagonal have a 6 side of faces, and it is also known as a base. Depending upon the where the position solid is placed, we can find out the different types of views like front view, top view, and side view. Using the views, we can clearly understand the diagram and the position. and continue. So the overall conclusion of hexagonal projection is important in engineering drawing, and it is useful for designing machines, buildings, and other structures. By practicing hexagonal solids, it's improve our drawing skills, and it is useful in many engineering fields.